Good day all. In this video, we will discuss about what is a energy signal and power signal. So for any given continuous time signal x of t, the total energy is defined as E is equivalent to limit t tends to infinity integral minus t to t mod x of t the whole square dt joules. And the average power for the same continuous time signal x of t is defined as P is equivalent to limit t tends to infinity 1 by 2t integral minus t to t mod x of t the whole square dt, and it is measured in watts. So if we look at the energy, if we have energy, finite value for energy, that is, if we get a finite value for energy, then power will be equivalent to 0. So this is the condition for an energy signal. And for a power signal, if energy is infinity, then we will have a power, some finite value of power for some signals. Then in that case, it is called as a power signal. If the signal has infinite energy value as well as infinite power value, then that signal is neither energy signal nor a power signal. And here from this power value, the RMS value of the signal can also be calculated. So RMS value of the signal is equivalent to square root of power. So now we will discuss how to find out the energy and power for the discrete time signal x of n. So the total energy of the discrete time signal x of n is calculated by E is equivalent to limit n tends to infinity summation n is equivalent to minus n capital N to n capital N mod x of n the whole square. And similarly, the average power is P is given by limit n tends to infinity 1 by 2n plus 1 summation n is equivalent to minus capital N to n mod x of n the whole square. So this is the equation. As this x of n is a discrete time signal and it exists only a discrete instance of time, the integration in the continuous time equations are converted as summation in this discrete time domain. Here, similar to the continuous time signal, the energy E is finite, then it is called as a energy signal. Therefore, power will be equivalent to 0. And if energy is infinity, then power may have a finite value. Then it is called as a power signal. If both are infinity, both the energy value and the power value is infinity, then it is neither energy signal nor power signal. So now we'll move on to the problems in this energy and power signal. So the first example what we can take is find the power and RMS value of the signal x of t is equivalent to a cos omega naught t plus theta. So the equation for power is P is equivalent to limit t tends to infinity 1 by 2t integral minus t to t mod x of t the whole square dt. So now the x of t is nothing but a cos omega naught t plus theta. So that we had substituted that mod the whole square. So it will become a square into cos square omega naught t plus theta. So the a square can be brought out. So a square, as it is a constant, so we had brought out a square out of the integral. So a square by 2t into integral minus t to t cos square omega naught t plus theta dt. And we know the formula to simplify the integration further. We can apply this cos square theta is equivalent to 1 plus cos 2 theta by 2. So if we apply the integration inside this integration 1 plus cos 2 theta by 2, we get this equation. So here after distributing the integral, this can be written as this 1 by 2. As it is common, we can take it outside. So we get a square by 4t and integral minus t to t dt plus integral minus t to t cos 2 omega naught t plus theta dt. And now we will bring this limit t tends to infinity a square by 4t inside the integral. So here if we bring it inside the integration, here we get limit t tends to infinity a square by 4t integral minus t to t dt. So that will be our first integration. Second integration will be limit t tends to infinity a square by 4t integral minus t to t cos 2 omega naught t plus theta dt. So here if we look at this second integral, here this is in the form limit some t tends to infinity and a square by 4t integration minus t to t cos 2 omega naught t plus theta. So here this function is finite and bounded. So this integral will be equivalent to 0. So directly we can substitute this integral according to the mathematical property. This integral will be equivalent to 0. So now we have only this integral, first integral, so that we integration of minus t to t dt will give us t, and where the limits are t and minus t. So if we integrate, we get this a square by 4 capital T, and inside this integral if we solve, we get 2 capital T. So this will get cancel, and our answer will be p is equivalent to a square by 2. So this is a standard result for the signal x of t is equivalent to a cos omega naught t plus theta. So using this standard result, now we will solve one more problem. So this is our second problem, that is find the power for x of t is equivalent to 5 cos 17 pi t plus pi by 4 plus 2 sin 19 pi t plus pi by 3. So it is of the form cos omega naught t plus theta, and similarly the same way it is a sinusoidal signal. It is not going to make any difference. So we have to bother only about the amplitude for finding out the power. So here according to this result, standard result what we had got, here the first equation we can write it as this a, the constant a is 5 here, so we can write it as p is equivalent to 5 square by 2 plus the second constant value is 2, so we can write it as 2 square by 2. So here it is 25 plus 4 by 2. So the result for this signal, that is x of t is equivalent to 5 cos 17 pi t plus pi by 4 plus 2 into sin 19 pi t plus pi by 3 is equivalent to 14.5 watts. So now we look at the third example, that is x of t is equivalent to e power j 3t plus pi by 4. We have to find out whether the signal is energy or power signal. So first we will substitute in the energy equation. So energy E is equivalent to limit t tends to infinity integral minus t to t mod x of t the whole square dt. So in the place of x of t, we have to substitute this e power j 3t plus pi by 4. So before simplifying this, we need to first understand what this e power j theta, how it can be represented. So e power j theta can be represented as cos theta plus j sin theta. So if we take mod of this e power j theta, this is nothing but the real part square. So this cos theta is the real part and sin theta is the imaginary part. So mod of e power j theta is equivalent to square root of real part square plus imaginary part square. That is the square root of cos square theta plus sin square theta. And then according to the trigonometric identity, cos square theta plus sin square theta is 1. So the whole mod of e power j theta will be equivalent to 1. In the similar manner, this mod of e power j 3t plus pi by 4 will be also equivalent to 1. So we can substitute this inside the integral. So if we substitute this inside the integral, our integral will become integral minus t to t dt. So if we simplify, our answer will be 2t, and if t tends to infinity, this energy will be equivalent to infinity. So now we need to move for the power equation. So power is equivalent to limit t tends to infinity 1 by 2t integral minus t to t mod x of t the whole square dt. So till this we had found out in the energy equation, and this part is equivalent to 2t. So this 2t and 2t will get cancelled and you get 1 watt. So the power, this signal exponential e power j 3t plus pi by 4 is a power signal, and it is the answer is 1 watt. Power is 1 watt for this signal. Now let us take the discrete time signal x of n is equivalent to 1 by 4 power n u of n. So we need to find out whether this signal is an energy signal or power signal. So first we will substitute in the energy equation. That is E is equivalent to limit n tends to infinity summation n is equivalent to minus n to n mod x of n the whole square. So here in the place of x of n we had substituted this 1 by 4 power n u of n. So here because this u of n is multiplied with the signal, u of n is valid only from n is equivalent to 0 to infinity. So the integral limit will change from minus n to 0 to n. This minus n will change to 0 as the negative part is 0 for this u of n. So here this u of n will change the summation limit to n is equivalent to 0 to capital N. And this 1 by 4 power 2 into n. So this 1 by 4 square and into n. So that will become 1 by 16n. That is limit n tends to infinity summation n is equivalent to 0 to n 1 by 16 the whole power n. So this is our summation now. So we have to simplify this. So for simplifying that we use the standard result, that is summation n is equivalent to 0 to infinity a power n is equivalent to 1 by 1 minus a provided mod a is lesser than 1. Here the condition is satisfied. That is here this integral limit, the summation limit we will change. That is n is equivalent to infinity. We can change it. So we will write it as summation n is equivalent to 0 to infinity 1 by 16. So this equation, that is 1 by 16 the whole power n, can be written as 1 by 1 minus 1 by 16, which works out to 16 by 15. This is energy, so I can put it as joules. We will also try to find out the power for the same equation, that is 1 by 4 power n into u of n. So here the power equation is limit n tends to infinity 1 by 2n plus 1 summation n is equivalent to minus n to n mod x of n the whole square. So here this equation, if we simplify with this 1 by 4 power n u of n, we get summation n is equivalent to 0 to capital N 1 by 16 power n. So here we have this 2n 1 by 2n plus 1. So directly we cannot substitute this infinity here. So we look at we substitute, we simplify this summation using this equation. That is summation n is equivalent to 0 to capital N a power n is equivalent to 1 minus a power capital N plus 1 divided by 1 minus a, provided a is not equivalent to 1. So using this equation we had substituted this summation n is equivalent to 0 to n 1 by 16 power n, we had written as 1 minus 1 by 16 power n plus 1 divided by 1 minus 1 by 16. So this will work out to some fractional value. This square bracket will work out to some fractional value, and here as n is infinity, n tends to infinity, here we have to substitute this n as infinity. So 1 by infinity, this power becomes 0 here. So hence it is a energy signal. We can conclude that it is a energy signal. So let's look at another example, that is x of n is equivalent to cos pi by 4n. So here now we need to find out whether it is an energy signal or power signal. So if we substitute in the energy equation, that is limit n tends to infinity summation n is equivalent to minus n to n mod x of n the whole square. Here in the place of x of n we will substitute this cos pi by 4 n, and it is mod square, so it will result into cos square pi by 4 n. using this formula, that is cos square theta is equivalent to 1 plus cos 2 theta by 2. We substitute limit n tends to infinity, summation n is equivalent to minus n to n 1 plus cos 2 pi by 4 n by 2. So it cancels and we get 1 plus cos pi by 2 n. So then we can take that 1 by 2. This 1 by 2 can be taken outside, that is a constant. So here this 1 by 2 we can take outside. We can separate the summations. That is limit n tends to infinity, summation n is equivalent to minus n to n 1 plus limit n tends to infinity, summation n is equivalent to minus n to n cos pi by 2 n. So here this limit n tends to minus n to n 1 will work out to 2n plus 1. That is from minus n to minus 1, 0 and 1 to n. So this will be 1 n and this will be another n. So 2n plus this is 0. So 2n plus 1 times 1. So that is why this summation converges to 2n plus 1. And here if we look at this summation, that is summation n is equivalent to minus n to n cos pi by 2n. So here this cos n pi by 2n or n pi by 2 has this property. That is when n is even, this cos n by pi by 2 is 0 and n is odd, this will be switch from plus and minus 1. So the whole summation will go to 0. So we can ignore this summation. So here if we take only this summation, here if n is substituted here, this will become, energy will become infinity. So we will go for power equation. So power P is equivalent to limit n tends to infinity 1 by 2n plus 1 summation n is equivalent to minus n to n mod x of n the whole square. So here this half, that is the energy equation we had already calculated, that is nothing but 2n plus 1. So we had substituted here this 2n plus 1 and this 2n plus 1 will get cancelled and the constant value, that is 1 by 2 will remain. So this is a power signal. The answer is 1 by 2 watt. So in this video we had discussed what is an energy and what is a power signal and how to calculate if given x of t and given x of n. And when the power is energy is finite, then power is equivalent to 0. If energy is infinity, power will have some finite value. If both are infinity, then it is neither power nor energy. Then how to find out the power for the standard signal, that is x of t is equivalent to, this is a standard result, x of t is equivalent to a cos omega naught t plus theta. The power of this equation is P is equivalent to a square by 2. So directly if a question is asked like that, x of t is equivalent to 5 cos 17 pi t plus pi by 4 plus 2 sin 19 pi by t plus pi by 3, we can directly take only the amplitude and we can substitute and find the power value. Then the another example is x of t is equivalent to e power j 3t plus pi by 4. So how e power j theta it converges. So based on that we will simplify the integration and we will calculate the energy or power value. Then we went on to this discrete time signal. So while using this discrete time signal, we should be aware of this summation formula. So this is one example. This is another one, summation formula we need to note down. And then this is another example, x of n is equivalent to cos pi by 4 n. Thank you.